Hello, and thanks for joining us with Maths by El Profe Lo. We're going to be looking at a Chinese Remainder Theorem problem, and we're going to notice to see how this problem is used to, how this theorem is used to solve the system given by 2x congruent to 1 modulo 5, 3x congruent to 9 modulo 6, 4x congruent to 1 modulo 7, and 5x congruent to 9 modulo 11. Okay, so in looking at this system, we notice that the system is not written as x congruent, x congruent, x congruent. So that means that we have to figure out how to transform these congruences so that I just have x. Okay, so the first thing to always check is to see, hey, do I have a greatest common divisor involving all three of my terms in my congruence, so three of the items in my congruence? All right, well, over here, 2, 1, and 5, no. 3, 6, 3, 9, and 6, I do have there, that if I divide everything by 3, I have x is congruent to 3 mod 2, right? And over here, 4, 1, and 7, no. 5, 9, and 11, no. All right, so this 3x congruent to 9 mod 6, we've already converted. So that's good. Okay. The conversion for the others involves using multiplicative inverses, right? So if I was to think about the idea of a multiplicative inverse, and that is that my inverse, right, times my number, right, is going to be congruent to 1 mod whatever my particular piece is, right, so my particular moduli. Okay, so I need to think about what number times 2 is going to have a remainder 1 on division by 5. Right? And so if I think about this and I say, well, 3 times 2 is equivalent to 1 mod 5, that means that 3 is my multiplicative inverse. Okay? And over here, right, if I look on this one, right, 2 times 4, that's equivalent to 1 mod 7. So 2 is my multiplicative inverse. All right? And for this over here, 9 times 5, right, that's equivalent to 1 mod 11, because 9 times 5 is 45, and that's 1 more than 44. So 9 is my multiplicative inverse to 5, right? So what does that mean for us? What does that mean for us? What that means is I'm going to be able to come over here and say, I'm going to multiply each of the sides of that congruence by 3. This is fine. Over here, I'm going to multiply each of these congruences, each of the sides of that congruence by 2. And over here, I'm going to multiply each of this sides of the congruence by 9. Okay? Why do I do that? Well, 3 times 2 is 6, and 6 is congruent to 1 modulo 5. So really what I have is x is now congruent to 3 modulo 5. Right? This is already written in the form that we like, so x is congruent to 3 modulo 2. And that's fine. Right? And then over here, 2 times 4 is 8. 8 is 1 modulo 7, and then 2 times 1. So this is x is congruent to 2 modulo 7. And then over here, 9 times 5 is 45. That's 1 modulo 11. 9 times 9 is 81. And so on this one, I can say x is congruent to 4 modulo 11, right? I could use the 81, but 81 might be a bit large for my multiplication later on, especially if I'm doing things by hand, right? Whereas over here, this 3, yes, I certainly could say that for that 3, right, I might say, well, that's the same as 1 modulo 2, but I want to show you that it really isn't going to make a difference in our work. Okay. So now for our Chinese remainder theorem. 5, 2, 7, and 11 are distinct prime numbers, so therefore they are pairwise relatively prime. Okay, and I know that this big M is going to be 5 times 2 times 7 times 11, right? Which would be 5 times 2 is 10, times 11 is 110, times 7, so that means that that's going to be 770. Okay, my M1, M2, M3, and M4 here. Well, for this one, it's just going to be 2 times 7 times 11. So that's going to be 14 times 11. That's 154. Right? This one is going to be 5 times 7 times 11. So that's 35 times 11. And 35 times 11 is 385. Using the multiplication principle, right? I have 3 and 5, and then add 3 and 5. It's more multiplication by 11. Right, over here, I have 5 times 2 times 11, so that's 110. And over here, I have 5 times 2 times 7, so that is 70. Right? So now my next step in using the Chinese remainder theorem to solve this problem is I need to solve 154x1 is congruent to 1 modulo 5. And I need to solve 385x2 is congruent to 1 modulo 2. And I need to solve 110x3 is congruent to 1 modulo 7. And I need to solve 70x4 is congruent to 1 modulo 11. Okay, so we have our congruences set up, right? Are any of these relatively simple and relatively straightforward? Yes, it does seem right over here that x2 will equal 1 because 385 is an odd number and that will have a remainder of 1 on division by 2. So that's fine. Okay, let's see, for these other ones, might not be necessarily quite as easy, so let's check this one out here. Okay, so 154 on multiplication by 2 is going to end in an 8. That won't work for us. 154 in multiplication by 3 is going to end in a 2. That won't work for us. 154 on multiplication by 4 is going to end in a 6. That will work for us, so x1 is equal to 4. All right. Then over here, 110 times 1, that's not going to work. 110 times 2 is 220, and 220 is not divisible by 7, nor is it 1 more than divisible by 7. Right? 330. 330 seems like it should work. But let's just check this out. 110 times 3, right? Divided by 7. Subtract the 47, multiply by 7, that has a remainder of 1. So yes, in fact, x sub 3 will equal 3. And then over here, 70 times 1, that's not going to work. 70 times 2 is 140. That's not going to work because 139 is not divisible by 11. 70 times 3 is 210. And it seems like that'll work, right? And if we're not sure, oops, let's check this out. 70 times 3, that's 210 divided by 11. That's that. Subtract 19, multiply by 11. And yes, in fact, x sub 4 is 3. Okay, so now we have these solutions. So now the next step in solving is to say that x is going to be equal to, right, our summation of these products. Okay, so it's very useful to be nice and organized. Okay, And how do we put the numbers in for our products, right? How do we put the numbers in, right? It is going to be this summation of b sub I, m sub I, x sub I, okay? So I'll just go backwards. So x sub I, that's 3, that's 1, and that's 4. Okay. Then the m's, so that's 70, 110, 385, 154. So there's 70, 110, 385, and 154. Okay. And then we need the b sub i's. So for the b sub i's, that's these 4, 2, 3, 3. So that's going to be 4, that's going to be 2, that's going to be 3, and that's going to be 3. Okay, now remember, I'm going to put a little asterisk up by this one so that we'll see that it really and truly doesn't matter whether we used 3 or whether we used 1. And I'll put a little asterisk up here because we did say that, hey, 9 times 9 is 81, so really this could have been an 81 there. So put the little asterisk up on that one as well. And let's make that a double asterisk so that we know where we're comparing. Okay, so obviously with these numbers, more than likely you would have a calculator available to you to do your work. So 3 times 154 times 4 plus 3 times 385 times 1 plus 2 times 110 times 3 plus 4 times 70 times 3. All right, so that gives us 3903. Okay, so if that's the case, right, we have x is equal to 3903. Okay, and let's just double check. 3 times, did we type everything in correctly? 3 times, right, 154 times 4, that number, plus 3 times 385 times 1, plus 2 times 110 times 3, yes, plus 4 times 70 times 3. Okay, so that's 4503. So we clearly may have made an error in our work, and it looks like there was our error right there, right? That was a 10 rather than a 110. So it is always useful to just double check your work. So I should have had 4503, right? Not 3903. So always double check. So there we are with 4503, and that's going to be equivalent to something mod 770. Okay, well, how can we do that? Well, from that 4503, let's subtract 7070 times 3. That's 2193, and let's subtract 770 times 2. That's 653. And 653 is less than 770, so this would be 653 mod 770. Okay. Now, to show you that this would have been the answer if we had used a 1 here instead of a 3, let's check this out. Okay, and that is 3 times 154 times 4 plus 1 times 385 times 1 plus 2 times 110 times 3 plus 4 times 70 times 3, and that gives us 3733. And look what happens if I add 770 to that. That gives me my 4503, so we know that's going to work. And of course we can say, well, how can we know for sure it works anyway? Well, if I only had one 385 instead of two 385s, that means that I was 385 times 2 less that I didn't count. All right. Similarly, over here, if I had a 4 versus an 81, right? If I had a 4 versus an 81, that would mean that there were 77 times 70 times 3 additional items, right? And we can say, well, if I have 77 times 70, I know that I can divide 770 out of there and get my answer, right? So it is useful to try and keep things simple as you can, but it isn't necessarily the case that you have to. All right, so this is a long problem. If you're not familiar with how to solve, it involves quite a few steps of having to rearrange to get the Chinese remainder theorem to be able to work. And we do our summation, and that answer is 653 mod 770. Could we check to see that this works? Yes. We'll leave that to you to do. All right. This has been Maths with El Profe Lo. Thank you for your time.